Okay, hello. I am Fitzy from Fitzy Codes Things on Twitch and elsewhere. And in this video, I want to go over the results of a 3-hour stream of pain and destruction that resulted in a pretty cool project that I'm happy with. And it's a really good illustration of two different templates for utilizing Azure Functions. So if you're not familiar, Azure Functions is the serverless function offering from Microsoft through Azure. And it took me a while to get my head around what a serverless function actually is and what it's good for. The simplest way I can put it is to think of it, and this was pointed out to me, I didn't come up with this, to think of serverless functions or Azure Functions like light microservices. So the applications are still very much monolithic in nature. They're not optimized. They're not built for microservices style architecture where they're kind of broken into functional components that are split off into services and then talk to each other. I don't know how to do that yet. I haven't gotten that far yet. I just haven't had a need to. But I can absolutely see the benefits of offloading some features of an application. So getting them outside of your main application. So in my case, usually it's going to be a web application. So again, in my case, I'm typically deploying those to app services on Azure. And those have limited, when I say limited scaling, they auto scale if you set them to, but you have a certain number of threads that can be chewed up by your app service at any one moment without scaling up and paying a lot more money. So I don't want certain things tying up threads that don't have to. So my users don't have to wait and I'm not paying a bunch more money. So for instance, you could have a function, an Azure function that you set up to just handle sending emails. And you can trigger that function in any number of ways. I'm going to show you 2 ways in this project. But then what happens is when your application decides it needs to send an email, it says, "Hey, Azure function, go send this email." And your Azure, and then it's done. It continues on its merry way. It shuts the thread down, back to the thread pool. Next user is good to go. Whatever needs to happen can happen. In the meantime, your Azure function takes over in a separate process, and it's a very cheap process. I don't know that I will ever actually pay for an Azure function to execute. It's that cheap. Like it's absurd. But my Azure function then takes over, still can utilize the dependency injection and services and everything else I have set up in my main application, but its sole purpose is to send that email. Another really good example that I've used it for, actually the very first example that I implemented with Azure Functions, was offloading a CPU and disk intensive data export process. So taking what I normally interact with as very complex Entity Framework core objects, and then flattening those out and dumping them into an Excel spreadsheet. It's not that it takes that much time, but we certainly don't want to make our user sit there and watch a spinning icon while the server is chewing through 10,000 spreadsheet records. There's no point in that. So instead, I use a certain type of Azure function trigger to kick off. So I just send a message to Azure function, or send a message to Azure. My Azure function is looking for that message, and it automatically takes it up and says, "Okay, here are the details of the export that I need to kick off." Goes and does it, and then updates the database to say, "Hey, we're good. Export's done. Here's the file name," and my application can then refresh itself by Ajax, or they can refresh the page to say, "Okay, here's the download file, click, I'm done." In the meantime, they're free to go about their business and keep working and all that kind of stuff. So a lot of cool stuff you can do with Azure Functions. So let's go over what I actually have for you. So let's pop over here. And before we get into the code, let's just take a look. I've got the code pushed to both Azure DevOps and GitHub. Since I am primarily a .NET developer for my internal projects, and since I'm a Visual Studio, Azure DevOps, Azure stack. That's what I use. So I typically use Azure DevOps for my projects and managing them and keeping the repositories up and tracking issues and all that kind of stuff, because it's just all integrated and it's right there. Why wouldn't you use that? The other reason I wanted to have it on Azure DevOps as well is because I'm learning CI/CD. And again, since I use the full Azure stack from Visual Studio to DevOps to Azure itself, I wanted to utilize pipelines, CI/CD pipelines inside of Azure DevOps. So I wanted to build the project here, get the pipelines working like I like them, keep learning how to do that. They're not ideal pipelines, I can tell you that, but they do function. But obviously, most of the world uses GitHub, so the code's there too, and you can get it from either place. Links will be in the description of this video or in the blog post that you might be watching it inside of. So, quick overview. We have the basic README on the overview page, nothing crazy there. We have the code repo, solutions fairly clean, very simple. We'll go over the code itself very shortly. Then we have the pipeline section where you can see the the history of build processes that have kicked off from these pipelines. Same thing is over there on GitHub. Like I said, the same code. I maybe will look at doing GitHub action equivalents of the Azure DevOps pipeline functionality. I'm positive you could do it through GitHub. I just don't know how yet. So I might look at that. And if anybody else wants to take a look at that and shoot me a pull request, then by all means do so. But let's jump into the code so we can actually see what's going on. So what we have is tell you what, let's start with the HTTP triggered function. So this one is very simple, very simple. Think of this like a very light API, as in an API with one method, with one endpoint. So here is our function code. This is the entirety of the function code. Now, it's obviously a mock-up, and so what you see here is that we would, this is where we would connect to our email service and actually send the email. So you can either do it directly, you can set up dependency injection, which I'll show you on the next function that we'll look at. But this is just a very basic mocked up Azure function. I do have a sample request body class built so that we can read in the request body from a post request and deserialize that object with strong typing back to an email request body, and then we can utilize that object however we need to. Very straightforward. So I'll go ahead and run the project and show you how to invoke it. So when you run it, it's very, very straightforward. When you run it locally, it's going to start up and you'll see a list of the functions that are contained in your project with their endpoints. So in this case, we have this localhost address /API/send email. And that send email is the function name that I have specified here. So not the name of the class, not the name of the method, which is just run, but the function name assigned as a decorator on this method. So I will copy this address, and there we go. And then open up Postman, which is, and we'll just start from scratch here. Don't save. Don't save. Postman, if you haven't used it before, is a fantastic tool, and I've used other ones like it. I'm just switching to Postman, so I don't know all the tricks yet. But it's really, really, really good for testing your APIs, or in this case, an Azure Function endpoint. There's a lot you can do with it, including setting up test suites and all kinds of stuff. We're not going to go into any of that crap today. Instead, what I'm going to do is I'm going to paste that URL in here. I've changed it to a post request because our function only accepts post requests. And then what I need to do is, because our application is going to be expecting a JSON object, I'll select a raw body and build a simple JSON object. So that object is going to be the to address for an email. So we'll just say bob@example.com, and the subject is also expected. So hello from Azure Functions, and the message, which I think is the right name for the object. Yes, message. So message is going to be, hi, I was sent to you by an HTTP triggered Azure function. Awesome. No big deal. Very basic. And we hit send. It's going to go out and talk, and you can see in the output here, C# HTTP trigger function processed a request, which was sent when we hit this button. We can do it again just so you can see it. Come on. There it is. And there's our response. Email hello from Azure Functions sent to bob@example.com. Super straightforward. Nothing crazy here. Okay, so once you have pushed it to published it however you want to publish it to Azure, let's take a look at what that's going to look like and how you can grab the URLs you'll need for utilizing it. So let me pop over to Azure real quick. Okay, so I'm on my Azure dashboard now, and you can see I have my HTTP trigger template here, and it's been published. Pretty straightforward for utilizing Azure here. We'll click into it, then click into the functions themselves that are contained in this, and then there's our send email function. So we can click into that, and then we go to, is this the right one? Integration? No. Go to code and test. Sorry, still learning this stuff too. Okay, yeah. So we go to code and test, and then there's a button over here for get function URL. Now the key, or this is the like authentication key option here, is not utilized currently because we don't have a key set up. We have anonymous allowed. That is something that you'll have to take on as an exercise for yourself. I have not looked so far into how to properly secure and authenticate requests by HTTP trigger to an Azure function. I think it's very straightforward. I just haven't looked into it. I haven't implemented these in a real project yet, but I think it'll be very straightforward to figure that part out. So otherwise, we can just copy the URL to the clipboard. And now you can see if I come in here, I could just set up a new post request and paste that URL in, and we're back to the same thing. So copy this email, edit the body, set it to raw, paste the JSON object, and hit send. And there you go. Hello from Azure Functions. So awesome. Let's get back to the code for now, though, and we'll take a look at the other function that we have. Okay, so our second function is triggered by an Azure Storage Queue. So actually, let me just show you back in Azure what that looks like. We'll open up the storage account that we have set up. And so when you pull it up, you'll see right here you have containers. That's for like your actual files. So the blobs that you store on Azure will be stored there. I have no idea what tables are for. I mean, clearly they're tables, but I haven't used them yet. So, yeah. But what we're interested in right now are queues. So take a look at queues, and you'll see here I have, I don't know what that is. This is the queue I created. That's sample queue, and there's nothing in it right now. So yeah, this is where messages will get programmatically stored by your application, by a different part of your application typically. And then your Azure function will be monitoring this queue, and when it gets a message, it pulls the message off the queue, deletes it from the queue, and does its thing, whatever that thing is. So let's take a look at what the code looks like on that. That is right here. So here's our sample function. Clear that breakpoint. And you can see I have it set up with dependency injection. So we'll go over how that works in just a second. That's another big thing I wanted to sort of codify for myself, was how to do dependency injection and use the options pattern in an Azure function, because it's pretty much ubiquitous. Everybody's going to be using dependency injection with any kind of realistically built out application. I'm sure there's ways to not use it, but is kind of the thing. So I wanted to make sure I had learned exactly how to do dependency injection the right way and then demonstrate it for you guys. So here is my function. You can see the, and by the way, these things, these configurations are set up for you automatically. So if I was to go to add new project and select Azure Functions, and then I come in here and just say new function, the next thing it's going to do is ask me, probably I'm going to have to delete that. Oh yeah, okay, so there you go. The next thing it asks me is what kind of trigger do I want? You can do it with a blob, so you could set up a trigger so that you're monitoring a blob container, and as soon as a file is uploaded to that container, your Azure function sees it, pulls the file or gets access to the file, and can do something with it. So for instance, if you have images that you want to upload through your application, and then you want to have an Azure function take over and automatically resize them so that they're optimized for the web, this is how you could do it. You can have triggers based on Cosmo DBs. I don't know what event grids or event hubs are, but you can do that. We've already looked at the HTTP trigger. You can do IoT devices. You can do queues, which we're looking at now. You can do service bus stuff, which again, have no idea. And then this is one of the really cool ones that I'm going to make a lot of use of, the timer trigger. This is basically your equivalent of cron on a Linux system. So you can use, and it's actually using a cron expression here to set the schedule to automatically invoke an Azure function. So for maintenance style tasks, data archiving, or auto billing customers on a schedule, whatever it might be, you can set up an Azure function on a cron schedule to do that. So very cool. So let's get back out of here. And what I was getting at is when you select that trigger, it's going to set your function up with some boilerplate code that's ready to go. So really and truly getting started with this stuff is a lot easier than it seems. I was intimidated by it. I had never seen it. I didn't really understand what it was. Hopefully this video helps. And I guarantee you the boilerplates that are going to come directly from Microsoft are going to help even more. So in this case, our queue triggered function is just logging some stuff. So I have it log a configuration value just to show that we are using dependency injection and options and so on, and then log that the request was processed. Nothing crazy there. What is important to look at for the queue triggered function with dependency injection is that to set up dependency injection, we have to add a custom startup class. And I've also linked in the README for the solution the link to the Microsoft docs where it goes into a lot more detail about this. But basically, you're setting up a custom startup class that has this assembly tag up here, and I don't even know what that is. Obviously, it's some kind of data annotation, but I've never even seen one outside of the namespace. But it's basically telling the function startup project to use this specific startup class, which extends the or inherits from, rather, the built-in functions startup functionality. And once we're in there, we use the iFunctions host builder, which is very similar to the host builder that we get in a typical ASP.NET Core application. And we use it to build a new configuration so that we can pull from user secrets if we want to, from JSON files if we want to, environment variables, etc. And then we can just start registering our services. So in this case, I have a singleton to register my custom configuration that I've built here. And then I have this block here, which is somewhat unique to the Azure Functions way of doing things. This doesn't look exactly like it would in an ASP.NET Core application. But this is how we utilize the options pattern to pull in options that I've specified here and map them to a custom options object that is this. And then that custom options object can be passed much more easily to other services that I'm using with dependency injection and so on. So in this case, the Azure Storage service that I've written to sort of wrap around basic normal Azure Storage Service operations like uploading a blob file, downloading a blob file, deleting a blob file, and enqueuing messages to the queue. All of that's wrapped up in this custom Azure Storage service that I've built, which gets its options from the iOptions, or rather the options pattern. So that is what this startup is doing here. It's registering that options pattern instance. And then we add our typical storage service with interface, no big deal. And once we've done that, and actually if I look back at the HTTP trigger real quick, you'll see out of the gate, the boilerplate code that you get from Microsoft is going to give you a static class with a static method. No problem. It's normally perfectly fine. But once we want to use dependency injection, of course we can't use static typing or static instantiation. We have to use non-static instantiation. So just pull the static off the class declaration and pull the static out of the method signature, and then you'll be able to create your constructor, do dependency injection like you always have, and then utilize those injected services throughout your application. Very straightforward. Now, to run a queue-triggered function locally, you will need to have the Azure Storage Emulator installed, and if you just included Azure as one of your options inside of Visual Studio, you should already have it. There's also a link to the docs that explain how that works and gives you a link to download the storage emulator itself directly, but you will need that storage emulator, or, well, for now you need that storage emulator to test this locally. Unless you want to actually plug in a real connection string here. Here. Right now it's set to this use development storage special value that basically tells everything in .NET that utilizes this stuff to talk to your local storage emulator. No big deal. You can, of course, though, plug in a real connection string. Note this warning up here, though. I wanted to go ahead and include this local settings file. Typically, if you use the generated.gitignore, it's going to exclude. This gitignore comes from the boilerplate code, and it will exclude this local settings file, which is great because you don't want local settings being pushed with your repo, so that you have connection strings everywhere that you don't want them. I did not notice that the first time around, so I tried to fumble around with getting user secrets working inside a function, which you can do too, but you just don't need it because the gitignore that comes with it automatically excludes the local.settings.json file. And once you publish it to Azure, you're either going to be using the standard options on what amounts to the app service instance to set up environment variables, or you're going to be using key vault within Azure, and that's a whole different thing anyway. So if you want to test locally with an actual connection string to your storage resource on Azure, you can plug that in here and it'll just talk to that queue. No big deal. It is currently set up for local development. So let's see how that works. So what I'll need to do here is change to have multiple startup projects. So I'm going to start up my Azure Function Queue Trigger project, and I'm going to start up my Triggers project, which is badly named, but it's a basic console application that also has dependency injection, and that's what chewed up a lot of my time on stream today. But basically just uses my Azure Storage Service and enqueues a sample message for the function to consume locally. So yeah. So, okay, I didn't actually save that, so let me go back in here. Multiple startup projects, and so I've got those two projects set to start. There we go. And now if I hit start, we'll see two windows pop up. Okay, so there is the Azure Functions to be set up. Apparently I already had some messages in the queue. Interesting. Okay, I still had messages that had not been processed. That's weird. But in the triggers window, I probably should update the code so it gives you some, I don't know, feedback here. All you have to do is press enter, and it's going to write the message to the queue, and we'll see it pop up over here. There you go. C# queue trigger function process test message. Very straightforward. Hit enter over here again, and we're done. Cancel that. and you're good to go. So that's how you can test locally. Similar stuff once you have published the code to Azure. We can come back in here and we'll take a look at our resources. Let's go to the Queue trigger template. Actually, we'll come back to it. We don't actually need this. You'll need to set up, probably, if you want to be serious about this, you'll want to set up application insights, which is so awesome. And I'm really, really loving it the more I'm learning about it. So yeah, what I've got is we can look at our logs, and we'll take a look at, all we need to do is take a look at our, well, we can look at trace requests and at traces. So we'll start with request. We can run those so you can see these are the old ones that I did from testing. Time range, let's just do last hour so we know we're looking at fresh data. Okay, so no data yet. And here is that queue. This is the queue on Azure operational. And so what I'll do now is I'll just add a message, and it can be anything. So sample message hello from YouTube. And if you'll remember, our code for this function just does some logging based on what comes in. So no big deal there. So there's the message. And now if I hit refresh, the message theoretically should disappear in just a second. Try it again. Okay. So message is gone now. And I'm guessing it took so long. I'm wondering if something didn't break on my build process, if I don't have something maybe configured wrong, but we'll find out. Let's run it. Let's check our requests. It'll take a second for it to pop up here in Application Insights, but we'll be able to look at the request, and if there was a problem, we'll be able to identify what the problem was. So, okay, we'll leave that there. I'm going to start a new query, and I'll do exceptions in the last hour. Exceptions. Run that. See, nothing yet. And then we'll look at, nope. Do another tab, and we'll do traces. Okay, run that. And we need to set this to the last hour as well. Okay, looks like it is doing its thing. So let's take a look at our request again, see if we have anything yet. Nothing yet. Oh, it's taking so long. This is one of the problems. Okay, so the way I have this configured is I'm using the baseline consumption-based plan. And what that can mean is that you can have some really cold starts. So if you need extremely fast performance, you may want to look at the premium plan or another way to configure. Just be aware that if you're going to run Azure Functions on such a premium plan, it is going to cost you a lot more. In this case, I'm absolutely fine, even if it takes a few minutes in most cases to run. Not everything can be like that. We want our HTTP function to fire up pretty quick. But for this queue-based thing, where it's going to be typically behind the scenes kind of work, it's okay if it takes a little bit for it to kick off and run. The thing is, it's already run. I'm not waiting for the function to run. I'm waiting for application insights to catch up. But like I said, it still can take a little bit of time to get going. So in the last hour, looks like nothing has happened yet that it's triggered, that it's recorded. Come on. Okay, I will fast forward the video when we have data. Okay, so here we are. We have our results in Application Insights looking at the logs. So here's the request that came in, or the request that was recorded rather when the function triggered. You get a lot of the details. So the trigger reason was that a new queue message was detected on the sample queue, which is what this is set up for. But you notice there's nothing else here that shows like our logging. That's absolutely fine. So we'll come over to our third tab over here where I've looked up traces, which are literally log traces. And And if we start looking through here, and I'm sure we could filter this down a little better, you can see right here. Here we go. See, this is our log message. C# Q trigger function processed. Sample message, hello from YouTube. There you go. That's all our function actually does. It also does try to log the configuration setting that was in our setup, but I have not actually added that configuration option as an environment variable on the app service here on Azure. It was set up on the local settings, so it worked there. It's not set up currently in environment variables on Azure, so we get nothing, which is absolutely fine. That's what it's supposed to do. But you can see, and just to show you how it works if you need to debug a function that's not behaving correctly in Azure once it's on Azure, you can just very simply in App Insights run an exceptions report, and you get the full list of exceptions. And so this was one of the exceptions that I was running into because I forgot to set the environment variable that feeds into my custom options pattern style of configuration setup. So when I got down here, and you get the full stack, I mean, it's just like as if you were debugging locally. It's very straightforward. Where is the information? Yeah, value cannot be null, parameter connection string. It's right there. Tells you what you need to know. So that's pretty much it. That's all there really is to setting up those two different types of Azure functions. The code is extremely straightforward. Hopefully I illustrated well enough how to utilize dependency injection and the options pattern so that you can build those more robust, complex applications. Yeah, so if you have any questions, hit me up here on YouTube. There'll also be a link in the description to the dev community, which is where I do my blogging and such along with my website, and that's where I like to have any kind of discussions that we're going to have outside of YouTube itself. So if you want to pop over to dev community and join the conversation there, you're welcome to as well. I'll be happy to help if I can. I also know a lot of very smart people, so if I can't find the answer, I will find someone who can. But in any case, I'm going to wrap it up because I still have billable hours to finish up for the night. But appreciate you watching, and we will see ya soon. Thanks.